All right, welcome back everyone. We have 9.1 Intro to Trig Functions. Your learning goal is going to be to algebraically identify amplitude and the periods of periodic functions. So we're going to introduce two functions and then just ask today that you can find the amplitude and the periods, and then in the next lesson we're going to get started on actually graphing them. Now, we're going to start off with some introductory information, then we are going to do a Desmos, and then we're going to dive right in, okay? Now, there are two functions that we're focusing on are the sine and the cosine functions. We will not be doing tangent because it looks very different than these two. And these two are going to look very similar. Now, each of these is what we call periodic. It is a function, a function is periodic if it repeats at regular intervals, okay? So both of these will repeat themselves over and over and over again. The length of that repeating we call the period, okay? Now the midline is the line between the max and min vertical values. So, if I have a sine function up here that looks like this, the midline cuts right between it, okay? And then the amplitude is the distance from the midline to the max or the minimum. So if it went up again and came down like this, and let's say we were here and this was 1, then the amplitude would be 1, okay? Now, I'm going to do a brief, kind of a parent function for both of these, okay? And we're going to go like this, a little table here, and we're going to have our input theta and our output f of theta, okay? Now, you're going to really need to remember back to the unit circle about this. I'm going to kind of draw, a small one. All right, let's just draw like a little circle right here. Let's split it into 4 parts. And if you remember, the point here was 1, 0, right? The point here was 0, 1. The point here was negative 1, 0. And the point here was 0, negative 1. Okay, these are going to be the most important points. All right, now there were degrees for this, right? That'd be 90 degrees to go to 0, 1, but we also said that in radians this was 0, this was half of pi, this was pi, this was 3 over 2 pi, and then back to 0 again also was 2 pi. Okay, because these functions, we are going to look at them in radians, okay? And these are really the numbers that we need to use for our input for theta. So we're going to start off with 0, and then pi over 2, pi, 3 halves pi, these are the worst looking pi's ever, and then 2 pi, okay? And then the same thing for this one down here. Okay, so 0, pi half, pi, 3 over 2 pi, and 2 pi. Okay, now if you remember, all the sine values were the y values. So at 0, our sine was 0. So that's 0, 0. All right, at pi over 2, it was 1. So that's 1. At pi, it was back to 0, so we're back to 0. At 3 over 2 pi, it was negative 1, so now we jump down to negative 1, and then back at 2 pi, we are at 0 again. So what does this look like on your graph? Well, we go up to positive 1, we went down to negative 1, we started at 0, 0, and we went all the way to 2 pi, okay, let me change this color up here. Hold on. Let's get some blue in here. All right. We started at 0, 0. We went up, so up to 1. And then we go down, and at pi, we went back through 0. And then we made it all the way to negative 1 at 3.5 pi, and then back to 0 here. Now, of course, this would continue, right? Go on and on and on and on and on and on, forever. But we're really only looking at a single period, a single distance, where it goes from right back to where it starts, because this is periodic. and its period here would be 2 pi. Okay? So the period is 2 pi. All right. Now, that's what a sine function looks like. Okay? And now I know there's an a and a b value here, and after I draw the cosine one, we're going to talk a little bit about how these affect the graph. Okay? So, same thing here, right? We start at 0, 0. Cosine is the x value, so we already started at 1. See that red. And then at half of a pi, we were at 0. And then at pi, we were at -1. At 3.5 pi, we were at 0 because all the x values. And then back at 2 pi, we were at 1 again. All right? So this one's a little bit different. We start at 1, we go down to -1, right? We have our period, which we're going to want to draw this part first. So we got pi over 2 to pi to 3 over 2 pi and then 2 pi. Okay? So we start at 0, 1. So we're up here. And at pi and a half, we're at 0. And then at pi, we make it all the way to -1, just like right there. And then we cross back to 0 at 3.5. And then we make it back up to 1 at 2 pi. And so if we follow this, it's going to go down and up and down and up. And so if you look at the sine and cosine functions, they look like they're really just different stages of them, right? Because if you think about this, right? You look at it right here. If I looked at from there to there, well, that's the cosine function, right? They're really just kind of starting at different points. And so sometimes if I were to draw a cosine function, it could be hard to tell if it's a sine function that's just translated or moved over, right? So, you got to be very, very careful, okay? Now, this one also had a period of 2 pi, okay? And both of their amplitudes, because they went up to 1 and -1, that's a distance of 1 from the midline, so both of them had an amplitude, which is called amp, of 1, okay? All right, now, let's kind of refresh here. What actually made the amplitude 1? Well, that's going to happen with the sine value, or excuse me, with the a value here, okay? Whatever number that goes there is going to affect our amplitude. So if we had a 2 here, then the only difference about these functions is that they would have gone up to 2. Sorry, they would have gone up to 2. Gosh, come on. Up to 2. There we go. Up. It just does not like me today. I'm going to call that 2. Down to 2, and then back to 2 pi. So it would have stretched it vertically, but the period would still be the same at 2 pi. Okay? So this a value here, the a value contributes to the vertical, the vertical stretch and the shrink. Kind of, again, back to if I put like a 1/2 there, that would shrink the amplitude down. It would only go to a half, like this. Okay? If I put a negative there, right, that reflects it, it would go down and then like this. If I put a -1, right? Now the b value is something very different. The b value is going to tell us our amplitude, and it's also, in fact, let's do this in green so we can tell these apart. It's also going to do our horizontal shift. Oh, those are just poor choices right there. Okay. All right. Now, the way we find the period is with the formula of 2 pi divided by whatever b is. So if b is 1, because we just graphed this as if it was just, sine of theta, right? Or if this was just cosine of theta, just very basic, a 1 for a 1 for b. If we would have put a number there for b, we would have had a different period. This point would be in a different place, right? If b is 1/2, that would have given us a period of 4. This would have been stretched all the way out to 4 pi before it repeated once. If b was 2, well, 2 pi divided by 2, that'd be 1 pi. This whole thing here would have happened before it got into pi. And of course, we're going to go over this in great detail, okay? I'm just trying to prime you guys, because, look at how much information is on this page. And this is an introduction, right? There's a lot going on with this, all right? So, I want to bring us full circle here, all right? Graphing the sine functions is related to the unit circle. You definitely need that unit circle to kind of understand how this happens. It is periodic. There's a period. It repeats. We have an amplitude that stretches it up and down, and our period is going to stretch it horizontally. Okay? Now, picking these parent points are different based off the period. Okay? So, let me stop talking on this introduction. This has become much more than introduction. Okay? What you should take away from this page is just the basic details. Okay? Let's do a Desmos exploration. Let's see how that A and B really, truly, quickly shift it. And then I got 4 problems. It's going to be a super long video, so hang in there, okay? All right, so here we are on Desmos. I think this is going to be one of the more helpful Desmos explorations because I just gave you guys a ton of information really, really quickly, okay? So notice how we can see just how periodic a sine function is, okay? Now, if you look at the x values, they are numbers, so it doesn't look like it's in radians, but if you think about it, 2 pi, well, 3.14 is what we use kind of to abbreviate for pi. 2 times 3.14 is 6.28. And if you look at where 6.28 is for an x, that's right where this crosses for that first time. So it is still in radians. Okay. Now, we have an A value of 1. We have a B value of 1. Watch what happens as I increase the B value. You see how the amplitude increases? Okay. Right? And notice how its period hasn't changed. It's still going right through 6.28 where 2 pi is. Okay. Now, if I go below 1, see how it kind of it shrinks, it compresses, right? And then if I go to negative, see how it's going down instead of up from 0. It's just the opposite, right? It just flipped. See that? Look. Okay. All right, getting carried away there. All right. Now let's bring this back to 1. Okay. And then I have my B value. Now, we haven't seen what B does yet exactly. So watch the period. See how it's shifting out. Okay. We're just changing the period. It's going to the same height, right? But we're changing, its periodic cycle. Okay. And this is that horizontal stretch. Okay. Now, believe it or not, this is exactly how radiation works, right? Your cell phone is sending signals that follow wavelengths just like this, right? And they can tell by the frequency of it, by how many times, they can tell who's sending the message or what kind of message is being sent by how many frequencies they can count in certain periods, okay? Now, I hope this kind of helps you see, if I could just, let me quickly just change this to cosine. Let's do that. See if this will show real quick. Yeah, it worked. Okay, it's got a lot of parentheses, but it worked. It's the same thing here for cosine, but notice how it just looks like the whole thing is shifted over a little bit, right? And we think of it as starting from 1. Okay. All right, and A value affects it same way. Okay. So hopefully, kind of helped seeing it this time. We're gonna dive in and we're gonna do 4 problems. Okay. Now, even those examples included, the full graphing of them, that's just really there to help you understand what those sine and cosine functions are. At this point, you should be able to really do 3 things. Tell me what the amplitude is, tell me what the period, and you should generally know, that the sine starts here, right, as opposed to the cosine, okay? Now, what's the amplitude? All right, because this is an I do. It's the number right in front. So our amplitude is 2. What is the period of the function? Well, our B value here is 3, so we have to take 2 pi divided by 3. Normally you can simplify it, and this one you can't, so that's your period. And that's all we're really focusing on for this one, okay? Now, I know this one says I do, which I'm going to do this one, but then you guys will do the last one, okay? So even though there's a negative here, right, and there's no number, I guess what's kind of weird about this is our amplitude is still just a positive 1, okay, without the negative. But that negative does do something else. That negative will reflect your graph. And this is gonna get weird, okay? Because if you think about the sine function, if I kind of go all the way back, I know it's kind of erased here, but if I had a 1 and a negative 1, my sine function goes all the way up, comes back and crosses, you know, the amplitude is still 1 here, not a negative 1, even though it went to a positive 1 and a negative 1, okay? So we don't really include that negative, it's still just a 1. And for the period, we're going to, you know, we have theta divided by 4, and this is going to be a confusing part. So theta is your input, so that doesn't get considered, but there is a 1 in front of this, and so that 1 over 4 does get considered. So here you have 2 pi divided by 1 over 4, write that horizontally. 2 pi divided by 1 over 4, and keep change flip. And when you keep change flip, you just get 8 pi, okay? So now when you go and do your graph, okay, in the future, for future lessons, it's going to go all the way out to 8 pi before it repeats. Look more like that, okay? Now, here's the last one. I want you guys to go ahead. I want you guys to give this a pause and see if you can find the amplitude in the period. All right, so that one was a little bit easier, right? Your amplitude is 5. And your period, we have 2 pi divided by our b value, which is just 2. And so the period is pi because the 2's cancel. All right. Now, that's all I really got for you guys. Just a quick math talk. I will tell you that right now the computer science classes are, you know, we are programming audio. And audio is a sine or a cosine function because it operates in waves like this, right? Hence the term sound waves. So in order for them to even program that audio from scratch, they have to use sine functions in order to generate the data here for our digital audio. And all the audio that you love and listen to is really sound waves. And that, you know, without sine and cosine functions, we would not have digital audio. Okay? So that's my math talk. I hope you guys enjoy this lesson, and I'll see you guys next time.